Hey there, and welcome. Ever stopped and wonder, what is all this stuff around us really made of? I mean, everything. Today, we're going to break down the basic building blocks of the entire universe. So let's get right into it.
Okay, let's start with a little riddle. What does a super hard diamond, the air that you're breathing right now, and a can of soda all have in common? I know, they seem totally different, right? But stick with me here because there's a wild secret that connects every single one of them.
And by the way, welcome to Learn with Ease. This is what we do here. We take chemistry and just make it make sense. We're all about taking you from the basics all the way to feeling like a pro, one simple explainer at a time.
All right, first up, what's the matter? See what I did there? Seriously though, let's lay down the foundation and get a really clear definition for the star of our show today, matter itself.
So, here's the big secret. Matter is basically anything and everything that's made up of tiny, tiny particles. Think atoms and molecules. But here's the really cool part. Those particles are never just sitting there. Nope, they are constantly moving, buzzing, and vibrating with space between them. Every single thing in the universe plays by this one rule.
Okay, so if everything is matter, how in the world do scientists even begin to make sense of it all? Well, they do what scientists do best. They put things in boxes. They classify it, organizing everything into neat little categories so we can actually wrap our heads around how it all works. And this flowchart, this is our roadmap. Think of it like a choose-your-own-adventure for sorting everything in the universe. Now, I know it might look a little intimidating at first, but trust me, we're going to walk through it step by step. Let's start with the very first question it asks.
Okay, first stop on our map. The question is, can you separate it by physical means? What does that even mean? Well, think about picking the raisins out of your trail mix. You're not changing the raisins, you're just sorting them. Or filtering coffee grounds out of water. That's a physical change. You're not changing the fundamental stuff. Just by answering that one question, boom, we've split all matter into two huge categories. If you can physically separate it, it's a mixture. If you can't, it's a pure substance. The big difference? In a mixture, all the ingredients are kind of just chilling together, like in a salad. In a pure substance, everything is chemically bonded, locked tight.
Okay, let's dive into that pure substance box for a second. The simplest thing you can find here is an element. This is pure stuff, made of only one type of atom. Think about a diamond. It's just carbon, and that's it. You can't break it down into anything simpler. It's the end of the line.
But what if you take different elements, say hydrogen and oxygen, and chemically glue them together? Well, now you've got a compound. The most famous example, of course, is water, H2O. Two hydrogens stuck to one oxygen, and here's why it's still a pure substance. Every single little molecule of water is exactly the same as the next one.
All right, so now we know how to sort matter based on what it's made of. But we all know that the same stuff can look totally different, right? I mean, that same H2O can be solid ice, liquid water, or invisible steam. And that brings us perfectly to our next big topic, the famous states of matter. So let's zoom way in. This is what's really going on at the particle level. And honestly, the only difference between a solid, a liquid, and a gas is just how those little particles are hanging out. See, in a solid, they're all packed in tight, vibrating in place. In a liquid, they get a little more freedom. They can slide past each other. And in a gas, man, it's a total free-for-all. They're just zipping around everywhere.
And that microscopic behavior directly causes the stuff we see every day. A solid holds its shape because the particles are locked down. A liquid flows and takes the shape of its container because the particles can move around. And a gas, it'll fill up any room you put it in. I love this analogy. Solids are like students stuck in their assigned seats. Liquids are like students walking around the classroom, and gases, that's recess. They're running wild all over the playground.
But this all leads to the biggest question of all. Why? Why do they do that? What makes particles lock down, or flow, or fly free? The answer is this really powerful idea called the kinetic molecular theory. It's basically the official rulebook for this whole particle dance.
Seriously, this theory is the master key that unlocks everything. The core idea is simple. All those tiny particles that make up matter are always moving. And anything that moves has energy, right? That's the whole game.
So let's break down the rules of the dance. First, because particles are moving, they have what we call kinetic energy. That's just a fancy term for energy of motion. Second, and this is a big one, The hotter something gets, the faster its particles move. But there's another force at play. Think of it like a sticking energy. These forces trying to pull the particles back together.
Check out this graph for heating water. It shows this whole theory in action perfectly. As we add heat, that's the line on the bottom going to the right, look what happens to the temperature on the left. It goes up. This means the water particles are speeding up, getting more and more of that kinetic energy. But then, look what happens. Something weird.
See those flat parts, the plateaus? This is where it gets so cool. We're still pumping heat into the water, but the temperature isn't going up, not one bit. So where is that energy going? It's not making the particles faster. Instead, it's being used for one thing, to fight and break those sticking forces we talked about. This is the energy it takes to literally rip the particles apart and change state, from solid to liquid or liquid to gas. That's a phase change.
And this quote right here just nails it. The state of matter, solid, liquid, or gas, is all decided by a constant tug-of-war. It's a battle between the sticking energy holding things together and the moving energy that's trying to fly apart. Okay, let's wrap this all up. So what's the big takeaway here? What's the one thing you should remember?
Remember our riddle from the beginning? The diamond, the air, the soda? Well, here's the answer. They are all just collections of tiny, moving particles. That's it. In a diamond, the sticking forces win, big time, locking everything into a super strong solid. In the air, the moving energy wins, so the particles are just flying free as a gas. And the soda? Well, that's a mixture, right? It's got liquid particles and gas particles all doing that same energy dance together in the can.
Hey, if this helped things click for you, do us a huge favor. Give this explainer a like, drop any questions you have in the comments, and maybe share it with a friend who could use it. And for sure, make sure you subscribe to Learn with Ease, and turn on notifications so you don't miss the next one.
All right, I'm going to leave you with one last thing to chew on. We now know that temperature is just how fast particles are moving. So, what do you think happens at the coldest possible temperature in the universe, absolute zero, when all that motion just stops? Let me know what you think in the comments. Thanks so much for watching.